Hello ladies and gentlemen, and welcome back to Prospect Charter School's Algebra 1 course. Today we're going to be going over section 6.1, Solving Systems of Equations by Graphing. So before we can move forward, we have to know where we are and what we're talking about. Because if we don't know what we're talking about, how can we expect to learn? So the first thing that we need to learn is what is a system of equations. So a system of equations is a set of two or more equations that are related. So an example of a system of equations would be something like the set, of y is equal to 2x minus 4 and y is equal to negative x. This is a system of equations because there are two equations that are related. Now, to solve them, we need to find the location where they are equal to each other or where they intersect. So, to solve a system of equations, we need to find the values of the variables that make all the statements true. So, looking at these, I think the easiest way would be to just graph the two lines and see where they intersect. So let's go ahead and do that. So step one, draw a set of axes that are somewhat straight. And then we are going to graph one as the red and graph the other one as the green. So the red one is 2x minus 4. So we go to negative 4 first and make a dot. And then since our slope is 2, we rise 2 and run 1. Rise 2, run 1. Rise 2, run 1. So there is our red equation. For the green one, we start at 0, 0, and we drop 1 and run 1. And this one illustrates one of the first problems with systems of equations. If a system of equation lands on one of the nice little intersection points on the graph, it's really easy to tell where they are. But we're not always given that. Sometimes it's right in the middle of space and we're not sure what the values are. This would be a fractional output. But I think we can guess it because this is a 2. It's probably going to be dealing with 1/2. So this looks like it'd be at 1.5, which is a decimal answer and I don't like them, but oh well. And at negative 1.5. So we'd have an x-coordinate and a y-coordinate for where they intersect. Because the intersection of a system of equations would be the x and y value that make the statement true. Or make both of them true at the same time. So let's go ahead and look at another system of equations. Maybe this one will work out a little bit better. So let's look at the system of equations of... Let's see. Y is equal to negative 1/2 x plus 3. And y is equal to negative x plus 3. Or let's call it positive x plus 3. Now looking at this system of equations, I think we know where they're going to intersect. This one's going to be really easy. So on the first one we have negative 1/2 x plus 3. So we go to positive 3, and of course we're going to make them red and green. And the red one starts at 3 and goes down 1 runs 2, down 1 runs 2, down 1 runs 2. And then we get our nice beautiful red line, not to be confused with a Little Red Riding Hood, who is apparently terrified of puppies. At least big bad wolves. And then the other one is x plus 3, so we start out at 3, and we rise 1, run 1, and we go in both directions. Now this one is really nice because it has a really easy intersection point. Our intersection point, well, we didn't go anywhere left or right on the x-axis, so that would be 0, and our y-coordinate happens to be 3. So that the solution for this system of equations, which will always be an ordered pair, is 0, 3. So note, all systems of equations are answered by at least an ordered pair. All right. So the flaws with this system, or solving a system of equations by graphing, is of course, 1, you have to have perfect graphs. 2, you have to make sure that they always intersect on a point, like a whole number point, because if it happens in between, it's really hard to gauge those. And another one is sometimes those numbers are really huge. There are some flaws with it, but if you're just glancing at it, like a lot of people in economics do, they have something called a supply and demand graph, and where they intersect is usually their optimal point. So it's used a lot in economics, and it's great to be able to just glance at it and get a ballpark number as to where things will be. So in that respect, it's awesome, but when it comes to finding exact values, it's pretty awful. All right. Now it's time for the before you go work, or bug work. And your bug work for today is going to be section 6.1, hashtags. Math is awesome. Graphs are cool. Systems of equations are how you become a billionaire. Numbers 1 through 27 on. Now I know you might think, oh my god, Mr. O'Neill, that's a lot. Well, not really, because all of these graphs are really easy, and most of the time you don't even need a table to figure out what the graphs do. So yeah, no tables necessary. Alright, thank you very much. Good luck, and have fun.